Picture this, the sun blazing over an endless stretch of desert. A small team kneels beside an ancient ruin, brushing away layers of sand to reveal something that hasn't been seen in thousands of years. The imprint of a hand carved in stone. Now imagine that same feeling of discovery, but instead of holding a brush, you're holding a computer mouse. Instead of digging through sand, you're digging through data. That's what I want you to think about today. That archaeology isn't just about the past, it's about curiosity, observation, and discovery. The same forces that drive robotics, data science, and engineering today. The title of this presentation, How the Next Generation Can Decode the Past, is more than just words on a screen. It's an invitation. Because the truth is, you, the students sitting here, have the tools, the creativity, and the perspective to uncover hidden stories that even the most seasoned archaeologists could never. Archaeology isn't old-fashioned, it's a window into the future, seen through the lens of the past. In decoding that connection, that's where the magic begins. Most people think archaeology is about digging up old things, but it's really about solving mysteries. Archaeologists are detectives of time. They look at patterns, how artifacts are arranged, what materials were used, and how they form hypotheses about how people lived, loved, built, and dreamed. Sound familiar? It should, because it's the same mindset that scientists, engineers, and coders use every day. When you write a program, you test and debug it, just like archaeologists test a theory about a site. When you design a robot, you observe how it reacts to the environment, just like an archaeologist observes how ancient people adapted to theirs. Archaeology is STEM for the soul. It teaches us that beneath every layer, history lies a question. Why? Why did people choose this spot to build their homes? Why did they carve symbols into stone? Why did their civilizations rise and fall? And that question, why, is the spark behind every innovation ever created. So the big idea is simple but powerful. Archaeology isn't just about history, it's about the process of discovery itself, the same process that drives modern innovation. Let's clear up a common misconception. Archaeologists don't just dig, they document, they analyze, and they reconstruct stories. Imagine standing at an excavation site before the first shovel hits the ground. Archaeologists use mapping drones to create a 3D model of the area. Every square foot is measured and recorded. Every rock, every shard, and every soil layer tells a story. In the lab, those artifacts are cleaned, photographed, and scanned into a massive digital database. Pieces of pottery are reconstructed using 3D modeling software, and dating techniques like radiocarbon analyses tell scientists exactly how old they are. But archaeology doesn't stop at how. It digs deeper into the why. Why did this society trade shells with another hundreds miles away? Why did their art suddenly change style? These questions reveal patterns of behavior, our shared humanity across time. When you realize that a 1,000-year-old tool was once held by someone with the same hands, hopes, and fears as you, the past stops feeling distant. It becomes alive. Archaeologists aren't just uncovering artifacts, they're uncovering empathy. Archaeology today looks a lot more like NASA than Indiana Jones. We use drones to fly over ancient cities and take aerial photographs that reveal shapes invisible from the ground, like buried temples or forgotten roads. LiDAR, or light detection and ranging, sends millions of laser pulses through dense forests to map structures beneath the canopy. It's the same technology that self-driving cars use to see the world. Satellite imaging tracks changes in landscapes, helping us locate lost civilizations and protect them from modern threats like deforestation. 3D scanning and printing allow us to digitally preserve fragile artifacts, sometimes even reconstructing them when they're too delicate to touch. And machine learning helps classify pottery fragments or identify artistic styles faster than any human could. Archaeologists today are data scientists, engineers, and innovators. The same coding principles that make your robot move also help archaeologists decode ancient trade networks. So when you're learning Python, when you're debugging a program, or when you're experimenting in a lab, you're already training to uncover the world's oldest secrets. Here's the best part. You don't need to travel halfway across the world to be part of this. Archaeology has gone digital. There are online programs where students can join virtual excavations, labeling artifacts and photos, identifying ancient objects, or helping archaeologists piece together broken statues through 3D images. You can contribute to crowdsourced museum research where real institutions invite students to help catalog artifacts. Want to visualize ancient trade routes or population migrations? You can do that using the same data tools used by NASA and Google Earth. You can even use AI and machine learning to build models that predict where lost cities might be hiding using topographic and satellite data that's freely available online. And this isn't just helping, it's real contribution. Some of the biggest discoveries in the past 5 years have come from students analyzing data remotely. So, yes, you can be an explorer, a scientist, and a storyteller just from your laptop. The next great discovery might not happen in the sands of Egypt, it might happen on the screen in your hands. Now, you might be wondering, what does archaeology have to do with robotics? The answer is everything. Both fields rely on the same foundation: observation, patience, and curiosity. When you build a robot, you analyze feedback, refine your design, and iterate layer by layer until it works. Archaeologists do the same, except their feedback comes from the earth itself. When your robot navigates a maze using sensors, it's interpreting the environment, just like archaeologists interpret soil layers or artifact locations. Both disciplines rely on pattern recognition, both require system thinking, and both are powered by creative problem solving. In robotics, we use algorithms to model behavior. In archaeology, we model human behavior, why people made the choices they did. The core lesson: whether you're programming or excavating, the same curiosity that drives discovery drives connection. Archaeology and robotics are just two sides of the same coin, decoding systems to understand life. So, why does any of this matter? Because archaeology reminds us that every innovation, every culture, and every piece of progress started with people just like us. The first engineer wasn't working in a lab, they were shaping the first wheel out of clay. The first coder wasn't typing on a keyboard, they were carving symbols that carried meaning across time. By decoding the past, we see how ideas evolve, how creativity, resilience, and human connection are constants, even when technology changes. Archaeology also teaches humility. It reminds us that civilizations rise and fall, and that our progress today stands on the shoulders of those who came before. When we study the past, we're not just looking backward, we're learning how to move forward with wisdom. It's not just about history, it's about understanding what it means to be human. If there's one message I want you to take away today, it's this: curiosity drives innovation, whether you're digging into dirt or into data. Curiosity is what uncovers hidden truths. Observations reveal patterns. The more you look, the more you see connections others might miss. And discovery builds bridges between people, between generations, and between the past and the future. You don't need a trowel to be an archaeologist. You just need curiosity, patience, and imagination. The same qualities that once unearthed ancient cities are now powering the next era of innovation. And you are the generation holding that torch. So go out there, explore, decode the past, discover the present, and design the future. Because somewhere beneath the surface of what we already know, the next great discovery is waiting for you to uncover it.